We're going to talk about some research that we did at the end of last year. If you remember, part of the BSUG 2.0 mission was to not only deliver this lecture series, but also to start to actively create resources for the building simulation community. So one thing that we thought was going to be really useful within that was to do a building simulation market assessment on exactly what is the market penetration of simulation in the Valley area, architects and engineers, all local, to understand exactly, okay, how are people using these tools, are they, and try to get some quantifications and metrics around that. So this was created by the BSUG program. I led the project, and the graphics were done by Sierra Shaver. No, she's here. She should be here. We both have master's degrees in architecture. She's in the graduate program. I graduated back in 2010. So my background, for those that don't know me, that are online, is in architecture. Right? And so I started working in the lab as an intern and slowly became a research scientist. And I handle a lot of the building simulation efforts through the lab, doing both architectural and engineering-based simulation. And we do a fair amount of research on tool development and how to use the tools themselves. So this was all based around our experience through the lab with building simulation and really trying to leverage our contacts to try to get as many people to participate as possible. So let me go ahead. There we go. So the introduction to the document, so I'm sorry, essentially I'll be presenting a PDF report that we created, which was the final deliverable for this research as the presentation today. So this will be posted to our website after the presentation, and you can go ahead and share it, you can download it, and you can disseminate it as you wish. So I'll be basically presenting directly from the format of the actual reports. So in that report, there's a foreword written by me, which talks about the importance of building simulation and its increasing role in developing and designing energy-efficient built environments. And the main thrust of the foreword is really trying to point out some of the key indicators that I think that really point to the rising popularity and usage of building simulation. So the second paragraph is really full of a lot of different references. For example, I've mentioned the AIA is producing energy modeling guides, for architects to integrate it into the design process. On the other hand, ASHRAE continually develops energy modeling resources like ComNets or the Advanced Energy Design Guides, which are all based off of building simulation, trying to use that to leverage that tool to create guides for us to help design specifications for more efficient buildings. Also, some of the interesting metrics, we looked at the 2012 report of the AIA 2030 commitment. So out of the 104 firms that have signed on to this commitment, they have to report their, the performance of their portfolios, and also what percentage of the projects they touched use simulation to predict operational energy performance. So out of these 104 firms, they're some of the most major firms across the nation. 57% of the gross square footage of their portfolios use building simulation in some form. So I mean, that's a pretty high number in terms of the national firms that you can argue are the ones kind of leading the edge on sustainability and sustainable design. So that's, I think, is a pretty hopeful indicator that building simulation and its popularity is growing. Also, one thing that I mentioned in the foreword is that there's an enlightened client, I think, that's becoming more and more of a factor. In 2012, out of the Fortune 500 companies, let's see, there's a certain percentage that actually had to report sustainability and emissions data in 2012. And over 2/3 of those Fortune 500 companies reported that data in their end-of-the-year reports. So they're starting to at least get on board in terms of understanding there's demand for this type of accounting, and energy simulation, of course, plays a huge part of that. So the foreword's really about all these different milestones that are pointing to the increasing popularity of building simulation. There's an intro that talks about the intent of the project, and really the intent was threefold. One, we were just curious. I mean, we were genuinely curious on how many firms are using simulation, what programs are they using, and we really needed to understand that in a quantitative manner. We use colloquially all the time that when Kevin started the lab and Ari, came and started to really push building simulation, that barely any firms were using simulation in the manner they are today. but we never really quantified that. So we're kind of a couple years down the road, but we were interested to see where is that today. The second reason would be to serve as the beginning benchmark on a future look at how the market is going to adopt the usage of the simulation programs, right? So it's not only satisfying our curiosity for what is the current state, but it's the first step in benchmarking it over time. The third intent for this would be to use it as a way to effectively communicate the value of building simulation, right? Depending upon how many other firms are using this, it will serve as a huge motivational factor for other firms to adopt it as well, right? Peer pressure or the social norm seems to be the highest motivational factor across a range of a lot of different studies. So this is one of those steps to really understand where is everybody at in terms of this skill set. So to get into the meat of the report, the first thing talks about the sample size, right? How effective were we? Did we get a representative sample? How many people participated in the study? And thanks to a lot of the people here in this room and our kind of marketing efforts, we were able to get 27 total firms to participate in the study. 61% of those were architecture, 30% were engineering, and 9% were multidisciplinary. So they housed architects and engineers in the same house. Now, ideally, we would have actually broken the rest of the infographics down within 3 categories: multidisciplinary, engineering, and architecture. Although we didn't really have enough time to do 3 different sets of graphics, and you'll see why as we go through. So what we ended up doing is we combined the multidisciplinary firms with the architecture label moving through the study. So keep that in mind as we look at these graphics. The architecture side is including multidisciplinary firms as well. So what percentage of these 27 firms is it of the total population sample? So out of 31 total architecture firms in Boise, we got 19 to participate in the study. So that's 62%. And this is a fantastic number because if anybody has done any surveys, cold calling, cold emails, I mean, a good range is 5 to 15% in some of those campaigns. So the fact that we were really hands-on about going out there, talking to our contacts, trying to get them to really see the value in this, 62% is a fantastic number. I was really happy about that. But when we look at the actual number of employees that we touched, because remember we're trying to assess skill sets as well, we actually touched 88% of the employee population of architects. And this wasn't just architects with their professional licensure, it was any employees working within the architectural field, interns, draftsmen, architects. It was, a lot of it was dependent upon the understanding of the firms when we asked that question in the actual survey design. But it's beyond people with just their license. And what's interesting is that even though it's just 60% of the firms, 88% of the employees, we got most of the major firms within that 19 firms that did participate. So those are the ones that have multiple people versus the ones that didn't participate were a lot smaller practices. So that kind of skewed the numbers in our favor. So we had a pretty representative sample, I would say, of the people working within Boise. So this number 31 represents not a definitive number. It's an estimate. How we came up with that is we did some exhaustive internet searches for architecture firms in Boise, Idaho, and then we called every one of those numbers. There were 60. And we called each one of those numbers to see, A, were they still in business? And if they were in business, how many equivalent FTEs did they employ? And over half of them, or around half of them, the numbers were disconnected. But that's the way that we tried to come up with that firm sample. It was surprisingly hard to come up with. We approached the AIA, we approached ASHRAE. There were no organizations that had really good statistical data on how many architects are in the valley, how many architects are in Idaho. This data does not really seem to exist, so we had to do some legwork to figure it out. Yes, Chris?
Do the colored-in briefcases and people, do those represent anything or type of numbers in any way?
Sure, yeah, absolutely. So, one of these briefcases here equals 5 firms. So you can see that the total darker gray here is the total sample. And so you can see just by the amount of color of those briefcases that's the general distribution of those firms. So you can generally see that we got most of them from a visual standpoint. And then same thing, the actual numbers are the same. One of these people equal 50 employees on both sides, and the briefcases equal 5 firms on that side. It's a good question. You'll see that a lot of the way that we try to display this data is in a very dense way. We call these infographics because they contain a lot of different information. So we're trying to break them down to be able to allow different readings of information at different glances. So you should be able to take away a certain amount of information from just glancing at it, and then as you dig deeper and dig through some of the layers, you should be able to get more information. And if you want the background, you can actually read the paragraph descriptions that are included in the report. Oh, and feel free, please, to interrupt, ask questions as we go through these. I think it'd be a lot more interesting if we try to dig into something if it's not clear and have a discussion about it. Yes, sir.
Why doesn't it look like 61% of the briefcases are colored in on the top left graphic?
It's
Or 62%.
So it's 62% based upon the darker gray. So really the full sample size is this. The actual grid was just for graphic consistency. Yeah, so the actual total sample is just the dark gray filled in ones. Good question. So moving on to the next firm, this is kind of really the critical thing we were after, is do firms use simulation and how do they use simulation? Right, so out of the 19 firms that we surveyed, 42% use simulation in some manner, right? So that's kind of this inner circle, that's what the gray represents. The 58% do not use simulation. And so out of those 42%, we were interested in, well, how do they use simulation? What is the actual structure of how they use simulation or provide that service to their clients? So we gave them 3 options to choose from, and they could choose one or all. And it was, do you hire a third-party analyst to conduct simulation? Do you use simulation directly in-house to provide services to the client? Or do you hire a mechanical engineer, or does a mechanical engineer handle that aspect of the design service? So there's a distribution this way, 100%, and then out of those responses, we also showed distributions on this side too. So out of 100%, 38% said they hire a third party, 38% also use simulation in-house. That turns out to be around 5 architecture firms if you do the math. And 100% of those firms rely on the mechanical engineer to provide some aspect of that building simulation. And you'll notice that these don't add up to 100% because they were able to choose one or all of those options. So it's likely that some of these firms do all 3, right? They hire simulation out, they have some simulation capabilities in-house, and they also utilize mechanical engineering simulation services. But the important thing I think to take away here is that some architecture firms are using simulation in-house, and that a lot of them are still communicating with mechanical engineers. Yes, Justin?
What is the threshold for simulation, or what was your definition of simulation? Like a daylight study, or what would qualify as simulation?
Right. So in some of the text it talks about what is a simulation program. So we defined it as a time-step-dependent piece of software that's being used to analyze energy or daylight, essentially. So beefed up spreadsheets like HAP would still qualify because it is time-step dependent. More simplified spreadsheets, you can start to draw that line, right? So a lot of it has to deal with how we ask the question in that case. But it's mainly time-step dependent software programs is what we defined it as. It's a good question. So on the engineering side, it's interesting. So out of the 8 firms, 92% use simulation, and only 8% don't use simulation. So that was something that was interesting to see, that only a very small fraction of engineering firms, mechanical engineering firms, aren't using simulation. And a lot of that will have to do with the types of projects they work on, and we'll talk about that a little bit later. And then so out of that 92%, they were offered the same 3, how do you use simulation? And you can see that 100% said that they do simulation in-house, which is kind of what we expected. And then we saw that 38% hire a third party. We assume that's us with the lab. A lot of these firms, we've had working relationships with them. So this hiring a third party comes down to them hiring out our work or potentially other energy consultants as well. And then 50%, I think essentially is them working with other mechanical engineering firms to partner with them to use their simulation services as well. So there's a lot of sharing going on, and there's a lot of in-house simulation going on as well. Any questions about this guy? No, there's a lot of circles in this graph, but it's really just showing two distributions and 2 different types for 2 different disciplines. That's good. Is it clear? If there's something, just let me know. So then the next thing that we wanted to look at is what is motivating these firms to use simulation. because that's an important question for why a firm would adopt it, what's their strategy on using it, so on and so forth. So we similarly provided these different categories for what might motivate them. There was also an other category, so any written-in categories are located in this as well. The total number of responses are located across the bottom, and then these colored bars are the percentage. So once again, we added up all of the different responses. Firms could have selected all of these if they wanted to, and then we took that total number and looked at what that distribution was. So we could see what is the ranking of the most motivational factors to the least motivational factors by discipline. So for architects, you can see that using it as a design tool was the #1 motivational factor. And LEED certification was the second motivational factor. Now, we would have thought this was the other way around because LEED still seems to be driving a lot of the building simulation services used by architects. But these metrics start to say otherwise, right? And of course, some of these LEED certification objects, there might be some overlap because they might have selected both of those for specific projects they were thinking about. But in this case, it looks like using it as a design tool is something that is actually becoming more and more of a factor, which is great. Now, this also comes down to how we ask the question. What does it mean to use simulation as a design tool versus a documentation tool, as a certification tool? And I think we could have probably been a little bit more clear on this or really expanded upon that. My definition of using it for design would be using it in a proactive way to really drive the design of the building's envelope, form, massing, and specifications. Right? It's not enough to use it as just a documentation of you designing a building and then giving it to your analyst to report back to you on the energy. Right? And so depending upon their definition, it might have been used a little bit differently. So, learned a lot in terms of how you ask the questions is going to be really important on, qualitative and quantitative surveys like this. So, although this is heartening, I have a little bit of suspicion in terms of, what exactly is their definition of design. When we look at the, the engineering motivational factors for why they used it, there was a tie between the client requesting it, which is a good thing to see, and LEED certification. Right, so that seems to make sense as well, as a lot of the services are probably being driven by LEED, but the fact that the client is really requesting it is something that's nice to see as well. And you can see that code compliance for engineers is a lot higher on the motivational factor than for architects. Any questions about that one, motivations? Then we also have the demotivational factors at the end of the report as well. Yeah, so I think this was a write-in because that wasn't one of the original. Well, it might have been. I can't remember. But I think that if architects are using simulation, a lot of it is to determine loads, which has a key relationship to system sizing. So I think that might be why we're seeing it so high on the architecture side, which is something that I wouldn't have thought of. I wouldn't have predicted that would be so high. Yes? It should be the same. So you can picture this actually as being right there. But it's really about, utility incentive programs. So number 4 is how many projects use simulation in 2012. So part of the survey asked, how many projects did you work on in 2012 and roughly what percentage of those projects use simulation in some form. Now, ideally, we would be able to get billing hour information to really get those distributions correct. A lot of this is just based on estimations from the person filling out the survey. But a lot of people weren't willing to give up billing information data, and a lot of it just didn't exist for these types of tasks, depending upon the accounting of the actual firm. So this shows distribution along 2 different axes. You can see that out of the 1,163 projects in 2012, out of the firm sample, 8.4% use simulation in some form, and then we were curious on for what. So on the vertical axis, there's the difference between using it for LEED. In this case, 77% of that 8.4% used it for LEED versus 54% used it for design. And then once again, these numbers don't add up to 100 because they could have selected both, right? Some projects use it for both LEED and for design, right? So this was interesting because LEED is above the design category for the architects. But for the engineers, you can see that design was a much higher factor in how these projects use simulation versus just using it for LEED, although that was the highest motivational factor. And that probably has something to do with the breadth of projects that mechanical engineers work on. A lot of it they're using simulation to help design the different systems versus just using it as a certification tool like we might see more with the architectural practice and discipline. Also, it's interesting to see that only 8.4% of all these projects use simulation, but it's really important to understand the context of what those projects are, right? Because not every project really should use simulation, right? They're smaller projects, depending upon if they're pursuing certification, how important is energy efficiency to those projects. So, this is pretty coarse data in terms of this case. Breaking these down by project type would be a logical step for a future survey, so we could really understand what projects are ripe for building simulation. Out of those projects, how many people are using simulation to help design those, right?
Jake, I think this slide is really key. It'll serve as a nice barometer if we have the opportunity to do this type of evaluation again in 5 years or something like that.
You can imagine seeing how this starts to increase.
We can only imagine what percentage of the appropriate, of the projects would have been appropriate, but still, it's a really low percentage, surprisingly low.
Right.
Well, that I think
The confusion between lead and non-lead is unintuitive for me. Architects should think more about design as opposed to lead.
Right.
And engineers, being the, serving the architect for the building should be more for lead. But I found it unintuitive.
Yeah, absolutely. And so a lot of the text down here tries to explain some of those, and it's kind of interesting to see, what exactly was that split. And I think, part of that can be reasoned against, architects are probably using it more for lead because they don't have a lot of the other in-house simulation capabilities, so they don't have the luxury of being able to use somebody in-house to chase down a design optimization scheme. They're really hiring it out for lead purposes only because of all the fee structures and just what their scope is. So that's a whole nother story, right, of how that gets pushed through. But yeah, so for our online listeners, just some people making some general comments about how unintuitive that breakdown is and how interesting it might be to use this as one of the main benchmarking charts as we move through future assessments. Yes, Chris?
Thinking forward, Jay, you mentioned X% of gross square footage utilized in simulation.
Yep.
Does that number pop back up in one of these other slides, or is that only contained in the forward?
So that's statistics. So the question was, in the forward, we talked about the AI 2030 commitments metrics, and they said 47% of gross square footage of their project portfolios used it. We didn't use the same metric here because that accounting is a lot more rigorous in terms of what they have to submit versus what we had people fill out, on their own time. But this is, I think, a pretty good proxy of that as well. And one thing that's interesting about that's on a national level, and those are the firms probably that are leading the edge. So we would expect their percentage of projects to use simulation a little bit more often. But that's one reason why we targeted this particular assessment towards the local architecture and engineering firms, because we know that our Idaho design and built environment climate is much different than on the national level. Yes, Justin?
Not to dig too deeply into this, but you said that the numbers were fairly coarse on the amount of projects, so you're including things like tenant improvements and rehab projects and new construction all in the same thing.
All in the same.
So that may be why percentages look a little bit lower, because how much of that, 1,100 projects were actually just like tenant improvements?
Exactly.
Necessarily need.
No, it's a great point. So, another comment about what is the appropriate number of projects. This is a catch-all, all of them. That we could do in the future is what is just commercial versus residential. That would be a great split to see. What is new construction versus existing building, tenant improvements? What is that split? And one of the questions was talking about what is the primary kind of fields of building types that you work on, but we didn't quite get to crunching those numbers yet as well. We would have to ask the survey a little bit differently, and it have to be much more time intensive to get some of these other metrics a little bit more fine-grained. But it's definitely something to note for future assessments. All right, so the next question, so this was all about firms and projects, and there was a section about employees specifically and their skill sets and how many employees at the Valley know what types of simulation programs and so on and so forth. So the number 5 infographic is how many employees know simulation. So out of the 202 engineers, which is the outside circle, 10% of those of that sample know simulation, so around 20. And then we also want to know what is the split between energy and daylight. And so these numbers are intuitive from what we would expect. Engineers mostly know energy simulation, only a little bit know daylight simulation. And out of the 7.7% of the 323 architects that know simulation, there's a higher percentage that know daylight simulation versus energy simulation, which is what we would start to expect. But I think that breakdown is pretty interesting. This is another interesting context issue in terms of, is this 10% a low number? It depends on the appropriate level of, not all of your employees in a firm need to know energy simulation, right? Sometimes there's just one energy analysis position with a couple of support groups. Sometimes there's a whole energy analysis team. So, the fact these numbers look low isn't necessarily disheartening, but it's just another metric that we can use with the project information and the firm information to start to form a more complete picture of how simulation is used right in the Valley. So throwing a lot of numbers around, but remember these statistics are only as good as their assumptions, and we have to understand their context to really form meaningful conclusions from them. So we knew what percentage generally know simulation, so the next logical step would be what programs do they know, which I think is an interesting question to ask, especially because there's a pretty wide suite of projects that are available. So this breaks down exactly how many of those employees, so the 3.4% of the architecture employees that know simulation, 27% of those know eQuest, 36% know OpenStudio, 9% know Green Building Studio, and so on and so forth, right? So we actually get to see the programs that people are starting to adopt. So this would be another one of those interesting future benchmark questions. How does the market share of OpenStudio in terms of those employees start to increase over time or decrease, right? I think it's interesting to see that OpenStudio is the highest energy modeling program amongst architects. And I think a lot of that has to do with the lab interns going out into the workforce, because we surveyed a lot of the firms that they were in, so they were showing up on the survey as well. So age group would be another interesting metric to try to tease out of this particular demographic. So I think it was interesting. So most architects are using OpenStudio. Some are using ISVE, Green Building Studio's Building Information Modeling Integrated Energy Modeling Program. So that's a new trend that's just started in energy simulation, so I would expect that one to grow. Fair amount know eQuest, kind of the main horse of energy simulation. And looking at the engineering side, looks pretty interesting as well. eQuest is the most market share, which is what we would expect. But Energy Plus is at 35. So 35% of the roughly 20 employees that know energy simulation, a fair amount of them know Energy Plus. So we would expect these numbers to really start to shift over time, and that growth curve and that kind of speed would be interesting to be able to check out. And then of course Train, Trace, and HAP, 2 tools that are widely used as well amongst the architectural energy modeling population. So this is energy simulation programs. This 3.4% and 8.5%. Now we want to look at daylight simulation programs. So out of the 4.3% of architects that know daylight simulation, the highest percentage is SkyCalc. It's the most popular one, and that's essentially a really beefed up spreadsheet that incorporates TMY data, mainly used for top lighting big box stores, but it can also do some side lighting. But this is like a really beefed up spreadsheet, and its ease of use is something that's really attractive for people to use. And then you can see the next biggest one is 3ds Studio Max. It's a rendering software that a lot of architects learn in school, and there are some analytic capabilities with daylight and visual comfort that it can be used as well. So I think that's probably why it's the second most popular in terms of the architectural population. And then of course gets kind of spread around through the other ones. One thing that's interesting, out of the 1.5% of architect or engineering professionals, they just know SkyCalc. So the engineering daylight simulation capability is not very diverse, right? So that's something that you can take away from this as well. Or if you're interested in building that simulation capability into that firm, SkyCalc might be something that you would look at, or potentially competitive advantage might be gained if you go on to some of the other types of programs, right? So one of the key things, too, that we wanted firms that participated in this to come away with was a gauge of their competitiveness of their skill sets amongst all the firms in the Valley, right? If they were interested, they know kind of what programs are being used. If they think they're behind the curve, they exactly know where they're at in terms of some of the other market penetration of the software, right? So the last infographic, and this actually should be viewed as a spread. So these are the demotivational factors organized from most demotivational or least motivational on the left to the least on the right by the architects, right? Because there was only 8% of engineering firms that said they didn't use simulation. So there was only one response, and that was that design doesn't provide design service. But if we look at some of the architectural responses, the top three really speak a lot to, I think, the problem with building simulation still currently, and the fact that it takes too much time to learn in terms of its learning curve. The programs are too expensive. That's true in a lot of cases, although there are a lot of free tools out there. And that it's not requested by clients. And that could be because of the appropriateness of simulation on projects issue. It can also be that they don't see the value of doing simulation, right, in terms of how does it affect their triple bottom line? How does it affect marketing? How does it affect the building in general, right? So I think that a lot of this is the value proposition of building simulation and how it's still kind of the tools are developing to something that is more integratable across the design spectrum, that everything is starting to become quicker, faster, better for results. So I know we definitely understand some of the timelines that it takes to integrate building simulation. But as tools get better and become more evolved, that's going to start to get smaller and smaller. And I think we would start to see some of these factors become mere perception or start to even go down. So these are the four on the left. These are the four on the right. So some of the other things that people identified: difficult to integrate into projects, doesn't add value to projects. This is the firms themselves thinking that versus the clients. Isn't the obligation of the architect was one that we wanted to kind of gauge. Do architects think that it's solely in the engineer's courts versus what is the value of technical analysis on the architectural side? And then, of course, doesn't provide design service. And their architects think that is a demotivational factor. So that was interesting to see as well. So the last thing, so I looked up some methodologies on the diffusion of innovation of technology, right? And this comes from Rogers. This is a textbook used in a lot of kind of technology classes, but it's a way to gauge where you're at in the adoption process of any new technology or software that comes on the market, right? So depending upon which one of these kind of quadrants that you fall into, you are considered an innovator, sorry, it's a little hard to read, early adopter, early majority, late majority, or a laggard. So I thought it was interesting to plot some of the different key metrics that we found through the study along this curve and see exactly where everything is. So A is the 42% of total architecture firms that use simulation. So they're all considered the early majority in terms of they are right almost at that 50% mark between majority and minority, right? So it's about half saturated, another way that you can see that. 92% of the total engineering firms use simulation. That's B. That's over here. So if you're a mechanical engineering firm that doesn't use simulation in a meaningful way, you might consider adopting it, or the fact that you might be considered a laggard if you're down there. I know, right? But I think that that's the power, and that's one thing that we hope to see. Right? I mean, you can imagine if the architecture mark was down here, then you may not need to worry about it as much. But if it was more over here, then it's something that we could use as a way to push simulation, right? That we could communicate the value because of where the actual norm is. Strangely enough, it's right at the 50% point in that case. 15% of the total architecture firms use in-house simulation. So that wasn't just of the firms that use it, how many use in-house simulation. It was of the whole study sample. And that's 15%, so that's C. Boom, right there. So you can consider that if you are one of the architecture firms that use in-house simulation, that you're getting closer and closer to this innovators mark, right? In terms of competitive advantage, what types of services do that offer? What is the value? There's something to be said about that, right? And so the further we go to the left, the more interesting it becomes in terms of, what is something that we can build into our firm that would be different, right? So that is that. Number D, or letter D, is 7% of projects in 2012 use simulation. So part of the diffusion of innovations chart is the adopters, and then there's also market share. So I kind of plotted it on both to kind of see where they fell. So that 7% is here, and it's also pretty low in the overall market share. So if you're trying to understand what is the market penetration or saturation of simulation, it looks pretty low. It looks low if you're looking at the market share line. It looks like those projects that do use it are more and more innovative, which I would say there's a pretty clear argument for projects that do use simulation, although in the minority, are the more innovative projects in terms of energy efficiency and sustainability goals. So it's kind of interesting to understand where it's at there. But of course, we know that this market share line is all contingent upon the appropriateness of those projects and if they should use simulation or not. So there's some context there. The last thing was 35% of the engineers that know simulation can use Energy Plus. They are on the early majority, and we also can point to a lot of indicators of Energy Plus being, programs that are being accepted for incentive programs across the U.S. and being more supported by the federal governments. So it's interesting to kind of track that number as well. You can see that engineering firms that do that are part of the early majority. So just trying to plot some of the key metrics and benchmarks on this diffusion of innovations chart to try to draw some of those conclusions across from it. Also, the takeaways talk a little bit about more the appropriateness issue of the projects, a little bit about where we think the development process is within the software, the time frame that it takes to use it, the integration of the across different platforms. So mainly we're talking about the future implications of benchmarking and kind of where simulation is at with this conclusion section. Yes, Sherry.
With the 2030 assumptions that during the were there any of those questions that you could plot them there and
The one that we could probably do, there's only really 2 questions they're asking about energy simulation. Are you using it to predict operational performance out of all the gross square footage? Then also, do you plan on going back and monitoring energy afterwards? Those are the 2 things that they ask. So we could plot the 47% of projects that use it here and here and kind of compare it, but there would need to be some assumptions about, like we said, those are the more innovative firms. It's on a national level, but I definitely could just add that to this particular chart as well.
I think you sort of get to how you use these charts. Probably most importantly is to use it consistently, but
right.
How you define the population. For example, 35% of the people who do simulation do Energy Plus. So they're early majority for people who do simulation, but they're probably innovators considered amongst all the engineers.
Right, exactly.
Something to keep an eye on,
Right.
So defining that is open for discussion.
Right, absolutely. But yeah, so that is version 1.0, the first generation of some of the metrics that we got. There's a little bit more data that we could crunch. Like I said, we also asked about what types of simulation services do you provide, system sizing, like 2D heat flow modeling, energy simulation parametric capabilities, but we just weren't able to get those quite into the study. But there are things that we could do for the future, or retroactively go back and mine the results for additional graphics down the road. Any questions? Yes, Justin.
I don't know if this may be more of a common or just kind of general question for you to get your input, but what would you say, or do you think that there's any correlation between the adoption of technology and software for production of drawings, like say BIM versus CAD, and firms using simulation as software moves more in the direction of BIM and integrating the engines that go along with these simulations? Do you think that that is going to expedite the adoption of simulation in the market?
Absolutely. So the question was about, how does the new trend of like BIM integrated energy simulation, how do we think that's going to affect market adoption and the trends that we're trying to capture in this report? And I talk a little bit about that in the intro and the takeaways in terms of, I know we at the lab see that as one of the next big thresholds for building simulation. It's just starting to come out and become more popular now. There's the kind of Revit to simulation export process, which is a hot topic. And there's also Revit 2014 is building energy analysis deeper and deeper within actual Revit. So I think we're going to target some of our presentations this year on those specific topics, although you'll have a good chance to give some of that feedback in the survey. But we really see that as one way to really solve some of those building the time issue questions, cost, and overall integration. Because I mean, if you can do energy simulation in the Revit model that's already being done by the architects, I think it opens up a lot of communication between them and the engineers and just getting them on board with simulation in the first place. So I think it's going to be a really powerful force as we move forward. Yes, Charlie?
You said earlier you didn't take any age data or ask any questions in the survey about age, right?
Correct.
So in the future, that seems like a pretty interesting one to track in terms of who's coming out of school and what they're learning and who's taking over for projects and stuff. So I guess that's just a comment. One other one is you didn't have any survey for building owners or clients, right?
Correct. Yep. This was just for the architects and engineers locally.
It would be kind of interesting to see, what their knowledge of, simulation is and what their, the question of value and how they value it or don't value it, or their understanding of, if they're using the project, what value or what it's bringing to the project.
Absolutely. An owner-based survey, that would be a really important part of, this overall picture as well, because we see a little bit in this the importance of the client championing energy efficiency and sustainability as a driving force. So directly surveying them would be, I think, very beneficial. And even down the road, maybe not yet, but even operators, right? There's a lot of talk about using simulation to help commission buildings. And so I'm sure it's not even on a lot of their radars, but they're probably within that kind of innovators category, right? So yeah, surveys that target the building owners and then potentially in the future operators could be really interesting.
How much time do you think the folks who completed the survey spent giving you information? I know it's probably hard to exactly say.
Anybody want to volunteer that information? I know there's some people in the audience that filled it out. I would guess, though, depending upon how ready they're able to harvest some of their, how many projects did we work on in 2012, I would say anywhere from 15 to 30 minutes. Also, the questions about the employees are very difficult to get, right, because you have to almost ask every employee in the office, right? So we really tried to work with the firms and say, we could come in and ask everybody. We could poll if you'd like. We could come up with a separate survey that you could send out an email. Or, if there's like it only takes like 2 minutes to do it, but you have to have everyone together. So depending upon how they structure that, that could increase the time or decrease it very well. Like for even like the lab, 12 people, no problem, just to announce, hey, how many people know Therm, raise your hands, Heat, raise your hands, stuff like that. But some of the larger firms, it might be pretty difficult to do.